Alright guys, this is the video for the graphing quadratics numbers 5 and 6. So in this equation here, again we can see that it's in standard form. So things that we can get from standard form, first thing I'm going to notice is the y-intercept. Again, remember that's when x is 0. So if we were to plug in 0 here, here, and here, that means that we would get y equals negative 8. So 0, negative 8. Is where we'd go from there. Pretty much everything else, we are going to have to rewrite this to help us out. The only other thing I could get from this is that it is going to be, the parabola is going to be opening up because my a term is a positive 1/4. So it's going to be opening up. So positive 1/4. So to get our x-intercepts and our axis of symmetry and vertex, we are going to want to go ahead and factor this. So the first thing I'm going to do is I'm going to find my x-intercepts by setting this equal to 0. Okay. And to start solving, I'm going to go ahead and get rid of that fraction by multiplying the whole side by the reciprocal of 4 over 1. And because the other side is 0, remember it doesn't impact that answer, so that's going to distribute. That's going to cancel that out. We get x squared plus 4x minus 32. And this helps us to factor it a lot easier. So again, remember we want to think about what are the two numbers that we need to make a multiple of negative 32, but they add up. When you add those factors, it's a positive 4. And so if you think about that, that would be 8 and 4. So we're going to have x and an 8, x and 4. And remember the larger sign, so we have a positive 4 in the middle, so that means that our larger one needs to be positive and this one's negative. So in factored form, we can see that our x-intercepts are going to be negative 8 and 4. Now once you have your x-intercepts, remember that helps you with your axis of symmetry. The axis of symmetry goes directly through those 2 points. So if we know our x-intercepts, we know our axis of symmetry, we can just average them together. So negative 8 plus 4 divided by 2. So that means that our axis of symmetry is x equals negative 2. Well, once you have that, that's the x value for the vertex. So we can simply plug that back in to find the vertex. Now, you don't want to go into your factored equation. Okay, because we solve for when y was 0. We don't know what the y value is. So we want to go back to the original function here. So we're going to do 1/4 times negative 2 squared plus negative 2 minus 8. Well, negative 2 squared is 4, and 1/4 of 4 is 1, plus a negative 2 minus 8. So that's negative 10, so that's going to be a negative 9. So that means when x is negative 2, my vertex is negative 9. So now I have all of my key points that I can go ahead and graph. So my x-intercepts, negative 8 and 4. My y-intercept, 0, negative 8. My axis of symmetry is negative 2. Let me go ahead and put my ruler there. This just happens to be right in the spot I need it. Okay. And my vertex is negative 2, negative 9. All right, so you can see that we've got 4 points on there that helps create our curve, and they're good anchor points to help us out. The other thing is, take a look too. I don't even have to plug in and make a table if I want some other points, right? This is the axis of symmetry, so it's like a line of reflection. So if I wanted to, right, notice that this is 2 places to the right. So if I go 2 places to the left, there's going to be another point right there. So that's another way to kind of anchor in a couple more points before you try to draw in your parabola ever so carefully. Okay, there you go. So that's what that one looks like. So you just have to watch out for that fraction as your leading coefficient. Okay. All right, let's go to the last problem here. notice, okay, we're going to always start off noticing what form it's in. It is in vertex form. So because it's in vertex form, we're going to take the opposite of that number in this one. So the opposite of that is going to be my x value. It's -3, -1. Well, if that's my vertex, then it's my axis of symmetry is going through that point. So x equals -3, right? We can also tell that it's going to open down because of that negative sign, right? So it's going to be facing down, concave down. All right, now to get to the x-intercepts and the y-intercepts, this is where you might want to go ahead and solve them. The other thing is, though, too, again, y-intercept's a nice, easy one, so let's start there. It's when x is 0. And we're finding that y value. So I'm just going to plug in x is 0 up here into my function. So g of x equals -0 plus 3 squared minus 1. G of x equals, well, 3 squared is 9, but there's a negative sign out there. Technically, I should replace that x. If I'm writing it in function notation, it should be 0. So that way I know that my y-intercept is 0, -10. Okay? So for the x-intercepts, right, like, let's go ahead and just plot what we have so far. Right, so 0, -10. There's my y-intercept. And let me go get my ruler for my axis of symmetry. -3. And my vertex is -3, -1. Well, and we already know it's going down. So by just looking at this so far, right, if this is my vertex and I have a y-intercept, the only way to go from my vertex to that y-intercept is for it to go down. And we know it's going down because that's the sign of the function. So that must mean if it's going down, it's actually not going to intersect the x-axis. So I don't even need to waste time trying to factor this because it's not going to be factorable. So the thing is, though, if it's not factorable, remember that doesn't mean that it's not a function. It just means that it doesn't cross the x-intercept, so it doesn't have any roots. Okay? The other way that we could find that out as well is we can go ahead and convert this to standard form. So we get g of x equals -x squared plus 6x plus 9 minus 1. Distribute that. All right, and so some things to think about is like, okay, well, if that's my leading coefficient, right? Okay, so 2 factors of 10 that add up to 6. Well, they don't exist. All right, the other thing is too is remember, if you're getting confused, you could always check the discriminant. So the discriminant is b squared minus 4ac. So my b value in this case is -6, so that's 36. I don't know why I'm putting the square root sign. We don't need the square root sign for discriminant. Okay, so we get 36 minus 4 times -1 times -10. Well, if I'm going to get 36 minus 40, and that's a negative. I can't take the square root of negative. That's going to be no real solution, right? So since it's no real solution, it just means, it doesn't mean it's not factorable. Again, it's not that it's not factorable. It's that it's not going to cross the x-axis. Okay, so there are none. Right? So because of that, well, how are we going to finish graphing this then? Because we only have 2 points, and that is not really enough to kind of create a nice parabola, and we need more anchor points than that. 2 options. Well, one, we have our y-intercept. Use your axis of symmetry to help you out. Well, look at your axis of symmetry. How far away is the y-intercept? 1, 2, 3 places to the right. So again, it would reflect over that. So 1, 2, 3 places to the left. Now we can see that flow. The other thing to do is to go back to that idea of a table, right? So I might pick when x is -4. It kind of looks like it's going to go right there, but I'm not 100% sure. So when x is -4, I'm going to plug it in and see what I get for my y value. So I'm just going to kind of do some mental math. Negative 4 plus 3 is negative 1. Square that. That's a positive 1. We got that negative out there. So it's negative 1 minus 1. We're going to get a negative 2. So negative 4, negative 2. And again, I don't even have to plug in the other value on the other side because it's a mirror image of it. So I know it's going to go right there. Okay. I could keep going if I wanted a couple more anchor points. I could also try negative 5. What happens when I get negative 5? Negative 5 plus 3 is negative 2. Square that's a positive 4. But there's that negative sign out there, so it's negative 4 minus 1, which is negative 5. And it's going to be the same on the other side mirror image. So that helps give me a couple anchor points to lock in. Again, notice I didn't really need to switch between the forms as I was trying to find all the key characteristics for this graph. So if you're struggling, remember all those different shortcuts. Discriminant helps you quickly check to see if you're even going to cross the x-axis. There are times that you're not going to. So instead of frustrating yourselves trying to factor out the problem, right, we can check that and we can use the other characteristics to be like, that doesn't make sense. It doesn't look like it's going to go in that direction. So we can create a table of values to find a couple of other anchor points. So I hope that explained how to graph your quadratic functions. Let me know if you have any clarifying questions, and we'll pick up from there.